Mic on? Yeah, good morning, everyone. Morning. So as introduced, I'm Paul Marriott. I'm responsible for the platform solutions from SAP. And what I'd like to do in the next 15 to 20 minutes is share with you SAP's point of view on this topic of the Internet of Things. But before I do that, let me ask you a question. Who here remembers or used the Netscape Navigator to access the internet? I'm going to show, oh, look at that. We have an old and mature audience. So that was actually back in 1994. So we're just coming up to the 20th anniversary of Netscape Navigator. They changed the name, and there's lots of history behind that. But in 1994, we all started to actually use a browser that provided some value to us in terms of how we accessed the internet. Now, 20 years ago, and now, an awful lot has happened. And you think today in this networked world that we live in, and there's been many data points throughout this morning, and even in Jim's presentation, on the levels of connectivity that we have. And I'll give you some more data points, which, of course, in an IoT presentation are obligatory. So I think most of you are aware that we're very close to having more mobile phone devices on the planet than people. Will approach exceeding the population in the coming months, depending on which statistics you read. Here in Singapore, we've already exceeded the number of people in the population with a mobile phone. And of course, all those mobile phones, thank you, all those mobile phones are connected to the internet. I mean, there's very few devices that leave the Samsung and the LG and the Sony factories that are not internet enabled, right? So we have this huge amount of connectivity that's just coming from mobile devices, before we even get into topics like machine-to-machine and so on. Now, what I thought I would do is to visualize just the sheer amount of devices for you in a slide here. So in 2008, that was the year that there were more devices creating data on the planet than there were people. And you can see here through to 2015 and 2020, the gray circle represents humans, and the orange circle represents devices. And the projected estimate is that we will have 50 billion things creating data on the internet by 2020. So really just to visually represent to you the magnitude of the number of devices that will actually be out there creating data. Now, Jim alluded to this industrial revolution, and what we've seen over the last 200 years is organizations taking advantage of technologies to significantly change the way that they deal with their customers or run their businesses more efficiently. And we've seen that particularly in the last 40 years. And as you said, mainframe, client-server, internet technologies have all been adopted by companies. And it's not a question of if they'll do it, it's a question of when they'll do it. And with IoT, we stand at this point in the industry where there is a $14 trillion opportunity for businesses to go to that next generation of serving their customers and optimizing their businesses. And I thought this morning the example of Santander and the level of instrumentation in the city to provide not only better citizen services, but the ability to significantly lower the cost of running the various operations in Santander is a huge benefit, to the government. Now, one thing that I want to make clear here is, and you may be sitting here thinking, well, hang on a minute, devices have been generating data forever. You're right. If you look at someone like GE and their turbine business, they have technology that has been creating data for 15 to 20 years. And in fact, GE will state that they have about 100 million hours worth of data off all of their turbines around the world that is available for analysis. The challenge that GE has is, how do they get value from that information? And in my mind, there's three things that have happened in this shift, in this industrial shift with technology that are now enabled by the Internet of Things. The first is we can take data from multiple sources. So go back to the GE example, and Jim quoted this earlier as well. I not only have my machine data, which is massive volumes of data, often referred to as big data, but I can take multiple data sources. So whether I'm taking climatic and weather information, whether I'm taking demand information in terms of future demand expectation on that infrastructure, whether I take the field service information about how that's been maintained, the different suppliers that may be part of the maintenance of those turbines, all of these different data sources now can be combined to do a level of analysis on that data that gives us an insight that we've just previously not had before. Okay, and that is enabled in my mind by two things. Firstly, connectivity. Okay, so we have extreme connectivity at very, very low price, and that's become available to us over the last 3 to 4 years. There is nowhere in Singapore that you sit where you don't have free or very cheap connectivity. And the second is processing power. And this is simply Moore's law applied to computing. So if you look at what's happening around how data is stored and manipulated, we have extremes, magnitudes greater processing power in our infrastructure to take these huge data sets and do analysis and find information. And in fact, one of the things SAP has been talking about a lot for the last 3 years is the use of in-memory technologies to enable you to do this extreme real-time processing. Now, in every industry, you will find there are use cases for IoT. And I'll give you a couple of examples here, and we'll be sharing with one of my colleagues some of the pilot projects that we've done both here in Singapore and around Asia. But let me take a couple of examples. So connected logistics. I've been working with a company in Australia for the last 12 months. This company is the fleet provider for the 2 largest consumer retail stores across the whole of Australia. If you're from Australia or if you know Australia, there's 2 very large retailers, very commonly known in the high street. And those retailers provide all of the perishable goods that we'd go and buy from a cold storage, for example. Now, you think about the size of Australia, you think about the logistics in providing all of the delivery to all of those stores every day across Australia. Right? We picked one scenario around IoT to optimize their business, fuel efficiency. The trucks that this company now drive have 250 plus sensors on the truck that allow us to better understand how that truck has been optimized. So whether it's the tire pressure, whether it's the speed, whether it's the style of driving that the particular driver has in terms of how quickly they speed up or slow down the vehicle. We obviously can look at the route that particular vehicle takes in terms of its daily delivery schedule. And when you start to combine all of this data and receive all of that data in real time because it's connected, we can start to optimize things like fuel efficiency. Now, what we found with the IoT pilot that we did was that each truck every day, we can save hundreds of dollars, okay? Not such a large amount of money, but hundreds of dollars in terms of fuel savings on a daily basis. Multiply that by 1,000 trucks, that becomes tens of thousands of dollars a week, hundreds of thousands of dollars a month, and millions of dollars over a 2 to 3 year period. One scenario, and very straightforward 6 to 8 week project to actually demonstrate that capability to the customer. The other thing I would say here is in your industry that you sit in, IoT scenarios will be different for you even if you're in the same industry. So take something like retail. Burberry in the UK used this type of technology to provide the greatest customer service and maintain the highest brand quality attachment with their customers. Okay? They don't necessarily use it for trade promotions and real-time offers. They're using it to build a brand and customer loyalty with their customers. But if you come over here to a discount store, completely different retail strategy. What a discount store wants to do is offer a second pair of shoes at a 50% discount in real time based on that consumer walking into the store. So both in the retail industry, 2 very different scenarios. So you need to think about what's my business strategy and how do I apply this technology to the strategy that I want to improve my customer service in that case. What does this all mean? Well, we've heard a lot about this this morning. To simply describe what we SAP describe as the Internet of Things, well, simply put, what you see here is the physical things in the world that are now being instrumented through all of these sensors. That could be people. I wear one of these Fitbit bands. I'm sure 25% of you at least are monitoring your own fitness and movement and so on. Wearable devices, trucks I described, materials management, whether it's ingredients to combine a particular product or shopping carts or whatever it is. Then we have the virtual world where we have databases, high performance capability to store data. We have the cloud that brings this to you at a far lower price point than traditionally on-premise solutions. We have massive amounts of connectivity and of course mobile networks. Now, the real value of IoT is the point of intersection. Okay, so the point where the physical and the virtual world combine is the point where you get value. So for all of you in whichever industry you're in, you need to think about where is your intersection point. So whether that's the fact that I physically wear this wristband to monitor my movement, but all of the data ends up in the cloud, and over a period of days, weeks, and months, I start to get a profile of my health, and then I can compare that to my friends and family that wear the same device. Okay, I'm connecting the physical with the virtual to create value for me in terms of how I monitor myself and compare myself to other friends and colleagues. So this is where the real value happens. What we've chosen to do at SAP is create a platform that will enable IoT, but traditionally we're an SAP, we're an applications company. So we're building applications, IoT applications, which our customers are now starting to deploy. So whether that's around things like precision retailing, around things like more advanced predictive maintenance, so taking additional information into the existing predictive maintenance capabilities we have, things like fraud management, but also in the sports industry, there's some really fascinating technology that lets you monitor the Arsenal football game and what the players are doing and start to do predictive analytics around what the next likely move a particular player might make real time during the game. So that's good for the club in terms of their analysis, but it's an even bigger opportunity in terms of the value add you can provide to the fan base in terms of watching that football match live. So what I'd like to do now is to try and bring some of this alive for you. Ian Kimball, who's joined me on the stage, will take us through a couple of scenarios, and we thought we would start with perhaps a retail scenario, Ian. So take us away.
Certainly can. I'll just get my microphone on. Hello, hello, hello. Thank you. Well, good morning, ladies and gentlemen. What we'd like to do now is to show you some of the stuff that Paul's been talking about. The idea here is to start off with, we're going to show you some examples of customers and how they're actually using the SAP platform, that big data that Paul talked about, to actually make their business more efficient. Now, imagine I've just woken up in the morning. I didn't sleep very well. I had a bit of a bad workout, and I'm walking up to a vending machine. Now, all the information that we talked about how I've slept, what I've done, is on my phone. And I register with the vending machine by simply tapping here on the vending machine, and it says, "Hi, welcome back." And it's giving me here, it knows here that I haven't slept too well. Here it says, you didn't sleep too well, you've been exercising, perhaps need to. How about an isotonic drink? Nice idea, but I don't like that. What I like, my favorite is a Kit Kat. But it knows that my favorite is a Twix, but it knows that the Twix isn't available right now. The machine has run out of Twix. Oh dear, but it's offering me an alternative. So what I can do here is, what's the alternative? Oh, it's offering me a Kit Kat, a cheap Kit Kat. Okay, I'll take it. Ka-dunk, ka-dunk. There it is. Lovely. Thank you very much. Internet of Things in reality, as you can see here, ladies and gentlemen. But the tragedy here is with all that big data, why has this machine run out of Twixes? Okay? Now, because we're all using the same data structure and all the information is in there, it's in your SAP system, the SAP system is open, as Paul mentioned, to get more information in there, we can actually have other applications that will also interact with this vending machine to make sure that that tragedy of the Twix being in there never happens again. So if we switch to the iPad now, what we can do here is we can actually see here another application that they're using, which the dispatcher, the person who's actually responsible for replenishing the machines, is actually having a look at. The blue thing at the top here is actually a delivery truck, and currently it's planned to go to this vending machine to fill it up. If I look at that vending machine here, I can see that Twixes are running out of that vending machine. But what's happened now is an alert will be generated by my vending machine saying, I've run out of Twixes. So what we can do then, we can dynamically then use this alert, and we can say here, we can see here, okay, this machine has run out of Twixes. And now what can happen is all that information via the Internet of Things is sent back to the dispatcher central. And what these machines will communicate, and it will actually reroute the delivery truck to be more efficient. Now, this is what Paul was talking about how we can actually be more efficient using the Internet of Things, okay? And now we've got both vending machines are going to be full up. But because we're still using that data, we can take it even further. A business analyst at the vending machine shop can even take it one step further and analyze what's happening in all of the vending machines. Here, for example, I can look at my BW tools. Here I can see, what's happening, how are the sales going. I can look here. We can see also here predictive for the next 7 days what's going to happen to that vending machine, or what they believe on the basis of previous purchasing is going to happen. And we can take it another step further. Even the maintenance engineer, the person responsible for maintaining that machine, can also use this information. The machine can communicate, tell us information about the temperature inside the machine, tell us information about what's happening inside that machine, so we can proactively go out and maintain that machine. Very similar to the example we saw this morning of the large woodcutter. So that was one very quick demo that we wanted to show you, which was the example of vending machines. What we want to do now is to show you a second very quick example about how people in Singapore are intending to use it. If we switch back to the PC, you can see here now a connected car environment. And what you're seeing here is actually a simulation of information about cars that are currently driving around Singapore. At the moment, we're looking at about 5,000 cars that are active up here. And you can see over here we've got red and obviously yellow indicators showing things are happening. If I'm interested in the indicators, I can go over here, look at the analyze the warnings. And what I can do now is to drill down. And here you can see, like those trucks in Australia, we can actually see here information. Why has it got a warning? Because we've got a low fuel status. But we can also see down here things like the driving habits of the driver. What's his acceleration? What's his braking light? What's his score? And the Internet of Things will allow then new business models. For example, you can now charge, for example, people who drive well and don't brake very much, less insurance. Okay? If we go back here, we can have a look then also, for example, car manufacturers are very interested in using this because they want to analyze how their cars are performing. So, for example, here, if I go here and see actually what's wrong with a car, okay, perhaps I should select the right one. If I want to see what's actually happening in a car which has a red, I can actually find out why it's broken down. I can do even more here. I can actually drill down into a particular area and see what influence this is having on the traffic around here. So here you can actually see the other cars that are producing this information. And if the internet was fast enough, you'd actually see those cars moving. And finally, if we want to, we can also take then a whole load of statistics out of this. So for example, we can have a look at the top brands of cars that are currently on the road here. And you'll never guess that this was originally a German demo, because if we go here, oh look, a whole load of German cars in there. So that was it, ladies and gentlemen. Very quickly, we've just shown you 2 examples about how people are using the Internet of Things, using the SAP Big Data and synchronized platform in order to get that information and make value out of it. Back to Paul.
Thank you,
Thank
Ian.
you very much.
Very good. And Ian, you've frightened a whole load of Singaporeans there, because those driving habits and driving very closely behind someone else is a common habit in Singapore. So everybody, in years to come, expect your insurance premiums to start skyrocketing as you get monitored very closely. So what I want to do now is really conclude with what enabled those capabilities that Ian described. In my mind, there's 4 things that you have to have in an infrastructure. Whether you consume that from the cloud or you consume it and put it in your existing data center on-premise, that's up to you. But there are 4 fundamental things that, from an IT architectural perspective, we need. The first is, and I described this earlier, we need a real-time data storage capability. And we believe that, thanks to Moore's law and the ever-decreasing cost of memory, in-memory data processing, where we take massive volumes, billions and billions of records of structured and unstructured data, and we can process that in real time in an in-memory engine, is an extremely fundamental foundation that you need. Remember, IoT data is often only useful for a few seconds. Once something becomes 5 seconds or older, that information becomes no longer as useful to you. So the ability to process in real time is fundamentally provided through in-memory database technologies. We also need to consider the existing systems that you may already have in your environment, and this was brought up in a couple of presentations this morning. And there's a concept of this thing called event streaming. This is the ability to look for that needle in a haystack, a business event in an application that will trigger a particular business rule to respond to something that's happened within your organization. And we want to have an architecture that is non-intrusive to the existing applications that you already have. So this event streaming technology is a great way of being able to connect into the things you already have today non-intrusively, so you leave what you have, but be able to have that trigger, that business event triggering a new business process for you, for example, like the rerouting of the trucks in the vending machine demo. The third thing that we need is very advanced predictive analytics. Now, there are some very smart mathematicians on the planet that have built predictive data models that provide very accurate predictive analytics. So rather than just looking at the history of what's happened for the last 7 years and then me making a decision, I actually get predictive recommendations based on these very sophisticated mathematical models. Now, these models have been reserved to the supercomputers of the world to date, and a very small number of academic institutions being able to leverage that. If you think about what I just said about in-memory processing and the price point of in-memory processing, suddenly that predictive capability becomes available for the masses. And then the last thing is we need to consume through any device, whether that's a mobile device or any kind of connected device that we're either controlling or managing. Now at SAP, we build applications on this platform. We already have 6,000 plus customers worldwide using this platform. That's the SAP plug for the day. So 6,000 customers. We have about 600 of those here in Asia already. Our partners build applications, or you can build applications. But fundamentally, whether you look at SAP or any other technology vendor, these, in my mind, are the 4 things you need to consider to build an architecture for IoT. So with that, if you want to engage with us, either come to our booth at the break, or look at this Design Thinking with SAP.com website. Design Thinking is a Stanford University methodology for driving an innovation discussion and how you can build an innovation business case. So we offer this workshop for free to our customers. You can come to this website. You can engage with SAP if you're interested in running this type of workshop. So with that, my time is out, but thank you very much for listening to SAP's point of view. Thank you.